You know when you open an app on your phone and bam, there's a brand new feature that just wasn't there yesterday? It feels so seamless, right? Almost like magic. But behind that magic is this incredibly organized system. It's what lets hundreds, sometimes even thousands, of people build one single app without it all just falling apart. It's a disciplined dance, really. So let's pull back the curtain and take a look at the steps.
So yeah, that's the big question, isn't it? I mean, if you and a friend tried to write the same document at the same time, you'd just be writing over each other's sentences. It'd be a mess. Now imagine that, but with a team of 700 people all working on super complex code. How on earth do they coordinate? How do they stop it from becoming one giant digital train wreck? Well, that's exactly what we're going to break down.
All right, to make this all super clear, we're going to follow the journey of one single familiar feature, from just a simple idea all the way to your screen. And that feature is a brand new like button. Seems small, I know, but it is the perfect example to show how an entire team works together to bring something new to life.
Now, a feature isn't just built by one person. It takes a whole team. First up, you have a UI/UX designer who figures out what the button should look and feel like. Then our main players jump in. We've got Maria, she's a front-end developer, so she builds the part you actually see and tap. And we've got David, a back-end developer, who makes it all work behind the scenes. Along the way, testers act as our quality control, trying their best to break the feature to make sure it's solid. And finally, DevOps engineers, who are kind of like the architects of the whole delivery system, making sure that code gets from a developer's computer to your phone, smoothly and automatically.
Okay, so here's the crucial part. Maria and David are working on the same feature at the same time, but they're focused on different things. Maria's on the front end. She's building that visible button, making the little animation when you tap it. Meanwhile, David's in the back end, writing the code that actually counts the likes and stores it in a database. They are working in parallel, which means they need a really good system to manage all that work.
So how do they do it? How do they work side by side without constantly stepping on each other's toes? Well, the answer is a powerhouse duo, Git and GitHub. Think of it like this. Git is the system on their local computers that tracks every single change to the code, like a personal logbook. And GitHub is the shared central library in the cloud where everyone's work is stored and managed. And the secret weapon here is something called a branch. A branch is basically a developer's personal, safe copy of the project. So when Maria starts working on the like button, she creates her own branch. David does the exact same thing for his back-end work. They can experiment, they can make mistakes, they can perfect their code all in their own little bubble without any risk of breaking the main app for everybody else. It's such a simple idea, but it's absolutely brilliant for preventing chaos. And this brings us to the core rhythm of a developer's day. It's this little four-step dance they do over and over. First, pull. Before they write a single line of code, they pull down the latest version of the main project, just to make sure they're up to date. Step 2, branch. They create that personal, safe workspace we just talked about. Step 3, code. This is where the magic happens. They actually build the feature. And finally, step 4, push. When they've made some good progress, they push their changes up to their branch on GitHub, saving their work in that central library.
Okay, so Maria has built the button, David has made it work, but all their code is still living on separate branches. The next big step is to bring it all together. This is called merging, where you combine those separate branches back into the main project. But this is also where things can get a little interesting.
I mean, think about it. What happens if just by complete coincidence, Maria and David both needed to change the exact same line of code in the same file? Whose change should the system keep? It can't read their minds, right? So it just stops. It doesn't know what to do. And this isn't some rare disaster. It's a totally normal puzzle that happens every day in software development.
And this problem has a name. It's called a merge conflict. But here's the thing you have to understand. A conflict isn't a catastrophe. It's actually a safety feature. It's the system basically hitting the brakes and saying, hey, humans, I see two different instructions for the same exact spot. I need you to take a look at this and tell me which one is right. It forces people to talk.
And fixing it is all about teamwork. The system points out the exact file and the exact lines that are causing the problem. So what did David and Maria do? They just talk to each other. They look at both of their changes, they figure out which one to keep, or maybe they combine them into something even better. Once they agree, they just tell the system, okay, we've sorted it out, and the merge continues. It's that simple. Communication is everything.
So, Maria and David's code is now successfully merged together, but we're not done yet. How do we know their new like button didn't accidentally break, I don't know, the login page or the photo gallery? You can't possibly test everything by hand every single time. And that's where automation becomes our best friend.
This is where we meet the CI/CD pipeline. It stands for Continuous Integration and Continuous Delivery. And the best way to think about it is like an incredibly smart, super fast quality control robot on an assembly line. As soon as that new code gets merged, this robot snatches it up and puts it through a whole series of really tough tests.
So what is this robot? And it's often a tool called Jenkins. What does it actually do? Well, it grabs the new code, it rebuilds the entire application from the ground up, and then it runs thousands of automated tests in just a few minutes. It checks everything. And if even one single test fails, it immediately slams on the brakes, stops the whole process, and tells the team, hey, something's wrong, long before any user ever gets to see it.
Okay, our code has passed all the automated tests with flying colors. Our like button is almost ready for its big debut. It's stable, it's integrated, but it's not live for you just yet. It has to go through 2 final stops before it gets to your screen. The first stop is called the UAT server. That stands for User Acceptance Testing. You can think of this as the final dress rehearsal. It's a private, internal version of the app where the actual human team, testers, designers, maybe even managers, can play around with the new like button in a real-world setting. It's their last chance to catch anything weird before opening night.
And once everyone gives the final thumbs up in UAT, well, it's showtime. The code is pushed to the production server. This is it. This is the real live app that you use every single day. Opening night is here, and the like button is officially live for millions of users. The journey is complete.
So let's just trace that journey one last time. It all starts with a branch, that safe, private space to create. Then that work gets merged into the main project. Next, an automated robot runs a whole bunch of tests to check for quality. And finally, once it's all approved, it's deployed for the world to see. Branch, merge, test, deploy. That is the heartbeat of modern software development.
And that's the whole secret right there. This isn't just some random process. It is a carefully designed system. This cycle is what lets massive teams build these incredibly complex apps without it all turning into chaos. It keeps the whole process safe from big mistakes, organized so everyone knows what's going on, and efficient so you get new features fast.
So the next time you see a new feature pop up in your favorite app, you'll know the incredible journey of teamwork and technology it took to get there. It's a powerful system designed not just for building software, but for building anything complex, together. So now that you get the how, what will you build next?